Hello guys, welcome to my channel. This next video is all about resistance and resistivity. Resistance guys, by definition, it is the measure of the opposition to current flow in an electric circuit, which we already know that it is represented or measured in ohms. Then what is resistivity guys? It is the property of a material that measures how strongly it resists electric current, meaning in every type of material which will be used as conductor, for example, copper and aluminum wire, they have different resistivity. Okay, in this photo are the example of copper and aluminum wire, which are generally used as conductors. Later, you will learn why these two types of materials are usually used. To know the given resistance of a given length of conductor, there is a formula R is equal to ρ times L divided by A. In this formula, Greek letter ρ used to denote the resistivity of the material, where L is the length, and A is the cross-sectional area, and R is the resistance of the conductor. Just like a resistor guys, a given length of a conductor has also resistance. To measure the resistance, we have to use an ohmmeter, which is shown in the image. This image guys, you have to take note the first conductor at the top with a given length in a constant cross-sectional area. If you will decrease the length of that conductor, then the resistance will also decrease. And if you will increase the length of that conductor, then also resistance will increase. It only means guys that the resistance of the conductor is directly proportional to its length, because as the length increases, the resistance also increases. And as the length decreases, the resistance also decreases. But in the next image guys, as you can see at the right portion, there are three conductors with three different cross-sectional area. As you can see, if you decrease the cross-sectional area with the same length of that conductor, then the resistance will increase. And if you increase the cross-sectional area of that conductor, then the resistance will decrease. Meaning guys, cross-sectional area of a conductor is inversely proportional to the resistance. Okay, again guys, as a summary, which is based on the formula, as the length increases, resistance also increases. And as the length decreases, resistance also decreases with constant cross-sectional area. It is because the resistance is directly proportional to the length of the conductor. The area of the conductor will increase, the resistance decrease with the same length. And if the area of the conductor will decrease, the resistance will increase with the same length. It is because resistance is inversely proportional to the cross-sectional area of the conductor. Next guys, I will show you on how to solve the resistance. Actually guys, there are two common units of the ρ resistivity. The first one is the ρ is equal to ohm circular meter over feet. In the formula, R is equal to ρ times L divided by A. Length is in feet, and A is in circular meter. Okay guys, the area is equal to d squared, where d is the diameter of the conductor. D is measured in mil, and 1 mil is equal to 0.001 H. Guys, you have to memorize this conversion because it is very important in solving resistivity or resistance. The other common units of the ρ is equal to ohm meter, where the length is in meters and the area in square meters. The cross-sectional area can be solved by A is equal to pi r squared or pi d squared over 4. Okay guys, the table 1 is the resistivity of common elements at 20 degrees Celsius in ohm circular meter over feet. And the table 2 is in ohm meter. Okay guys, you have to proceed with the examples. Okay, example number 1. Using the given, calculate the resistance of the following conductors at 20 degrees Celsius. Okay, for letter A, material is equal to copper, length is equal to 1000 feet, and the area is equal to 3200 circular mils. While example number 1B, material is aluminum, length is 4 miles, and the diameter is equal to 162 mils. Okay guys, example 1A. In this case, since the unit of the length is in feet and the cross-sectional area is in circular mil, then we have to use table 1, where the resistivity of the copper is 10.37 ohm circular mil over feet. Okay, substituting to the formula, we have R is equal to 10.37 times 1000 feet divided by 3200 circular mil. Okay guys, the answer in example number 1A is equal to 3.24 ohms. Okay guys, next example, example 1B. Material is equal to aluminum, length is 4 miles, and the diameter is equal to 162 mils. Okay, this time guys, aluminum is equal to 17 ohm circular mil over feet. Substituting the formula, we have R is equal to 17 times 4 times 5280 divided by 162 squared. We have to convert 4 miles in feet, so we multiply it by 5280. So the answer guys is 13.7 ohms. Okay, example number 2. A copper wire has a diameter of 0.325 inch and a resistance of 0.6 ohms at 20 degrees Celsius. Calculate its length. For example number 2, we just have to substitute it to the formula. So we have 0.6 is equal to 10.37 times the length divided by 0.325 inch times 1 mil divided by 0.001 inch squared. As you notice, we have to convert the diameter into mil, so we divide 0.325 inch into 0.001. So based on the result, length is equal to 6,111 feet. Okay, for the last example, using table 1, what kind of material is used in the construction of 39 ohm rheostat? A variable resistance if the wire has length of 266 feet and a diameter of 22.6 mils. Okay, what are the given? R is equal to 39 ohms, L is equal to 266 feet, and D is equal to 22.6 mils. So what is the material used? First thing to do guys, we have to solve for the resistivity. We have to use the formula R is equal to rho times length divided by cross-sectional area. Okay, using the calculator, 39 ohms is equal to rho times 266 feet divided by 22.6 mils squared. Okay, so based on the result, the resistivity of that material is equal to 75 ohms circular mil over feet. Okay guys, using the table 1 for the resistivity of common elements at 20 degrees Celsius, then it will be seen that the commercial iron has a resistivity of 75. So meaning guys, the material used in the problem number 3 is commercial iron. And by the way guys, both copper and aluminum are widely used as conductor because they were more economical than the other materials, unlike gold and silver, which are very expensive. Okay guys, I hope you learn again from my video. See you in the next vlog.